In this video, we will see an example on phasors. We have to do addition of these two sinusoids by using phasors. Question: given I1 of t is equal to 4 cos omega t plus 30 degree ampere and I2 of t is equal to 5 sin omega t minus 20 degree ampere. Find their sum. So first of all, we will write what is given. So I1 of t is equal to 4 cos omega t plus 30 degree ampere and I2 of t. Before writing I2 of t, here we can see it is given in standard form. So we can easily convert this time domain format into its equivalent phasor domain format. So I is equal to 4, this 4 at an angle. Here the angle phi is 30 degree. So this is the phasor in polar form. So polar form. Now we will write this I2. Also it is I1, so this will be capital I1. Now we will write this I2. I2 of t is equal to 5 sin omega t minus 20 degree omega t minus 20 degree ampere. Now here we can see we have to convert this sine into cosine form first, and after that we have to convert time domain format into its equivalent phasor domain format, and it is also called as phasor domain is also called as frequency domain format. So let's convert this sine into cosine. So to convert sine to cosine, let's go to the basics. So here this is plus cos omega t and this is minus cos omega t. This is plus sin omega t and this is minus sin omega t. We have to convert plus sin omega t into cos omega t. So we are going from here to here like this, and the direction of rotation of phasor is this. So if we go in this direction, that time it will be positive, but currently we are going in opposite direction, so we have to subtract minus 90 degree. Why 90 degree? Because the angle is of 90 degree. So it will be, the formula will be like this: cos omega t minus 90 degree is equal to sin omega t. Now we can change this sin to cos by subtracting 90 degree. So it will be I2 of t is equal to 5 cos omega t minus 20 degree as it is, omega t minus 20 degree as it is. Then we have to subtract 90 degree and ampere as it is, because it is current, so its unit will be ampere. Now let's simplify it. So 5 cos omega t, and here this will be minus 20 minus 90 degree, so this will be minus 110 degree ampere. Now it is in standard form. Now we can easily convert this time domain format into its equivalent phasor domain. So I2 is equal to 5 at an angle minus 110 degree ampere. So this is the value of I2, and here this is the value of I1. Let's say this is equation number 1 and let's say this is equation number 2. So therefore I1 plus I2 is equal to 4 at an angle 30 degree, 4 at an angle 30 degree plus 5 at an angle minus 110 degree. Now this is given in polar form, also this is given in polar form, and we know that here we have to do addition, and we know that addition and subtraction are better performed in rectangular form. Rectangular form. So what is rectangular form and what is polar form? So r at an angle phi, z is equal to r at an angle phi. This is called as polar form, and z is equal to x plus jy. This is called as rectangular form. Rectangular form. Now we have to convert this polar form to rectangular form. These two polar form into its equivalent rectangular form. So the formula is like this: r at an angle phi is equal to r in bracket cos phi plus j sin phi. So here the value of r is, first we will convert this 4 at an angle 30 degree. So 4 at an angle 30 degree is equal to r value is 4 in bracket cos phi. The value of phi is 30 degree plus j sin 30 degree. So therefore this will be 4 at an angle 30 degree. So 4 in bracket cos 30 plus I into sin 30. So it is 3.46, 3.46, then plus J2, plus J2. Now we will do the same for 5 at an angle minus 110 degree. 5 at an angle minus 110 degree. It is equal to 5 cos minus 110 degree plus j sin minus 110 degree. So this will be 5 in bracket cos minus 110 degree plus I into sin minus 110 degree. So it is minus 1.71 minus 1.71 minus j 4.69, 4.69. So 5 at an angle minus 110 degree. Now we got both the polar form into its equivalent rectangular form. So therefore I1 plus I2 is equal to, we can substitute I1 plus I2 is equal to this value. In place of 4 at an angle 30 degree, we will substitute this value. Let's say this is equation A and this is equation number B. So 3.46 plus J2, then we have to do the addition, but here it is minus, so directly we can substitute minus 1.71 minus j 4.69. So this will be 3.46 minus 1.71. 3.46 minus 1.71. So this will be 1.75, 1.75, and this will be 2 minus 4.69. So it is minus j 2.69. First we have to solve the real part and then we have to solve the imaginary part. So this is the final answer for I1 plus I2 in rectangular form. This is called as rectangular form, but we need the answer in we have to add these two sinusoids and get the sum of them. So let's convert this into its equivalent polar form again. So convert it into polar form. So this will be 1.75 minus j 2.69 and it is equal to under root of x square, that is 1.75 square plus minus 2.69 square at an angle tan inverse of minus 2.69 divided by 1.75. So if we solve this, we get under root of 1.75 square plus in bracket minus 2.69 minus 2.69 square. So it is 3.209 at an angle. Now here this will be tan inverse of minus 2.69 divided by 1.75. So it is minus 56.95 minus 56.95 degree, and this is in polar form of phasor. So therefore here we can write this is I1 plus I2 in polar form. Now we can convert it into its equivalent time domain format. So it will be I1 of t plus this will be I2 of t is equal to 3.209 cos omega t minus 56.95 degree, and since it is current, so its unit will be ampere. Also here we can check the value of omega is unknown, so we can substitute omega as omega. So this is how we can add sinusoids by using phasors. Don't forget to like, share and subscribe to this channel. Thanks for watching.